And when we have snow, I will tell you to watch Tegrity. And then I might have a quiz. Okay. Let's see, this is 4-2. Okay. 4-2 notes. So, if you did print out the 4-2 notes, hurry up and print those out if you want them, or I have them posted in Shobi where you could write on them if you have an iPad, but it takes longer to write. Please print your notes out before class. Oh. And let's see, I forgot to copy, I was going to copy the unit circle and go over that. It looks like this one, or during a, well, we don't really take a break in this class.
Is it on D2O?
It is on Shobi. Let's see. The unit circle, you could print this out. We'll go over it after we talk about the notes. Unit circle, way down at the bottom with no due date. The blank one, print the blank one out, if you don't mind. Okay, we're going to talk about 4-2. Okay. And I do have there's a Nearpod, but it doesn't have much in it, except it has slideshows. It has the slides, but my library. I'll start it. It does have one link. This is a live lesson, UOFEQ. You go to nearpod.com and get into that on the computer. It is really nice to be in the classroom with computers. Okay. Where did it stop working on your computer? No.
We literally.
Oh, there used to be. Oh, here it is.
Okay. Thank you.
You can hold on. Okay.
I haven't been working on it. I'm 15 years old. Yeah, it's running on Windows 98. I know.
Okay, so this is the unit circle, and I've got the filled-in notes posted now. But so trig and trig functions were first defined using right triangles but problems in calculus are solved using functions whose domains are a set of real numbers. So this book first introduces trig functions using unit circles and radians and a variable of t. I do want to pull something out. Okay. I posted this in Shobi, this page, on 4:1, second to last page of the filled-in notes. I had a typo. This is supposed to be a T, not an R. I kept trying to work it. No. Angular speed omega is theta, the angle divided by time. And it's usually in revolutions per minute. And for linear speed, we have to change it to radians per minute first. So I changed that to, you have to change it from revolutions per minute to radians. And in a circle, there's 2 pi radians in 1 revolution. So that's how you convert from radians per minute. So you get 90 pi radians on this example down here. And then linear speed is r, the radius times omega in radians per minute. And then you have to multiply that. And we leave the radians off. This is the bottom of the 4:1 notes. And so I had a, let me get that page. And so I did go through, we leave the radians off when we write it here. We have to convert omega, and there's 1 to radians per minute from revolutions per minute. And that's why we multiply it by 2 pi. We cancel the units. We get 90 pi minutes per minute. And we leave the radians off, so it's feet per minute. It's feet per minute. So as I was going over this, all right, that's the filled-in notes, which I guess I didn't have those. So I did. All right, so it's feet per minute. So back to 4:2. So we've got a unit circle. It has a radius of 1 because it's a unit circle. It centers at the origin, and the equation of it, because it's a unit circle, it centers at the origin, is x squared plus y squared equals 1. That's the equation. And in a unit circle, the radian measure of the central angle is equal to the length of the intercepted arc, and that's S. So you need to memorize the 6 trigonometric functions if you don't have them memorized already. Okay, that's what this slide says. Now, on this, these are definitions of the trig functions, but this is a special case. And as long as you memorize that when you're on the unit circle sine of t is y and cosine of t is x, you can get the rest of them by memorizing the stuff I tell you to memorize in under number 15. Memorize the reciprocal identities, if you don't already have those memorized, and the quotient identities. From number 15 in our notes. So number 15 in our notes is, so if you memorize number 15, you'll be able to figure out all of these. If you know that sine of t is y and cosine of t is x. So number 15 says, memorize, and it's hard to read up here because it's so faint, but I just memorized this one that I circled, so if you memorize these three and this, you got it. Oh, I also memorized this one. Well, no. Yeah, I guess I'd use that one too, but. So that's number 15 on a few pages back. So there's no point in, you don't have to fill your brain with all of this. If you just memorize that and then use it to find these in the special case. So, all right.
I don't know what to say, man.
What? Okay. Okay, so all right. So you were supposed to watch this. So this is I'm not going to go through this whole next example, but I will make the triangle bigger. This triangle. Make a triangle out of it. And this is P, I don't know if you can see that, it's the square root of 3 over 2 is the x coordinate. So this distance is square root of 3 over 2, and the y coordinate is 1/2, and this is our t, the angle t. And the radius is 1 because this is a unit circle. So you can use the stuff up here to find these, or I had this memorized. You should memorize these. Sine of t is opposite over hypotenuse. Cosine of t is adjacent over hypotenuse, and tangent t is opposite over adjacent. So you can find these, but so sine of t is opposite over hypotenuse. 1/2 over 1 is 1/2. Let me make that smaller. See the whole thing. Cosine is adjacent over hypotenuse, square root of 3 over 2. Tangent, you're going to put 1/2 over square root of 3 over 2. That means you're going to multiply through by, you take the reciprocal. Okay. All right, I really wasn't going to go all through this. So 1 over square root of 3. And then you got to remember how to rationalize the denominator. You don't leave the square root in the denominator. You're going to multiply by the square root of 3 over the square root of 3. Changes the look. And you get square root of 3 over 3. So that's the answer to that one. And you just, if cosecant t is 1 over sine t. So you got to memorize these things. Cosecant is 1 over sine. Secant is 1 over cosine. And cotangent is 1 over tangent of t. So you're just going to take 1 over the previous answers to find these answers, but you have to rationalize your denominators. So I'll write down what you get. You get 2 square root of 3 over 3, and you get square root of 3. And I worked it out on the filled-in notes, which I've now posted. Okay. So it goes through, and the slideshow goes through all this. Okay. This is a little thing. Let's see. 7 animated gifs that will make you instantly understand trigonometry. So you have to click on this blue box. Comes up. And so this is showing, here's what you think when you see the number pi. So you can copy this link. It's Business Insider 7 gifts, tree, sine, cosine, but that's showing you pi. You take a circle and roll it. It's a pi. 3.14. 2 pi radians. It's showing you that relationship. It's pretty cool. Showing you all these things, but this is the tangent function, sine over cosine. They're taking a unit circle, and tangent sine x over y. Here's, so I guess that's sine and cosine. Remember, sine is x. No, sine is y, your y coordinate. And cosine is your x coordinate. So it's making those waves there. All right. You can look at that. If you open it up in a window, you can leave it open. All right. So the next page. Okay, we're using the unit circle, and so the trig functions may be referred to as circular. So the unit circle, so the sine function changes the way the y value changes. Since sine t equals y, and the cosine function changes the same manner as the x coordinate change. So, I had these memorized from a long time ago. Here's the sine function, just one period. And here's the cosine function. That's just one period of it. So if you look at, this is 0 and this is 2 pi. This is minus pi and this is pi. So summarizing when they're increasing and when they're decreasing, an increasing function rises, and then we talk about, this is pi over 2, this is pi, 3 pi over 2. So I've got sine is increasing. Remember when we talk about increasing, decreasing, constant, we're talking about x values. So, and it keeps going. So actually this is talking about having sine. I should draw a picture like maybe it's showing this part of it, because I've got sine is increasing from minus pi over 2 to pi over 2. That's here, increasing. It's decreasing from pi over 2 to 3 pi over 2. So you got to figure out what part of sine I had. It depends what you're looking at, which period you're looking at. So this is pi. So if I want to go to 3 pi over 2. So I guess we had sine for these going from minus pi over 2 to 3 pi over 2. All right, cosine is increasing from minus pi 0, from minus pi to 0, and it's decreasing from 0 to pi. The graph is falling from 0 to pi. And tangent. Here's what the tangent function looks like. There's asymptotes here and here at pi over 2 and minus pi over 2. So the tangent function is increasing the whole period. So tangent increasing from minus pi over 2 to pi over 2. And it's never decreasing. Okay, that's increasing, decreasing. You got to get familiar with these graphs. Read the book. Increase and decrease. Cosine. So looking at cosine here. Tangent. Okay. All right. Now, reminder of what the quadrantal angles are. These are when the initial point, remember, standard position of an angle, standard position has its initial ray on the positive x-axis. And the quadrantal angles that are the ones that have the terminal ray on an axis. So the quadrantal angles between 0 and 2 pi are 0, pi over 2, pi, and 3 pi over 2. Okay, so if we look, here's our unit circle. If we just do 0 degrees here, this point is 1, 0. Okay? So if this is 0 degrees, so we're doing t equals 0 degrees, so then sine t equals y, and y is 0. Cosine t equals x, and that's 1. And then tangent t is sine over cosine is 0 over 1 is 0. And then you take 1 over these to find the rest. So cosecant t, I've run out of room. Because I wrote that. Cosecant t is 1 over sine is 1 over 0, that's undefined. Secant t, you gotta memorize that, is 1 over cosine, is 1 over 1, is 1, and cotangent is 1 over tangent, and that's 1 over 0 undefined. And you know, the next one would be 90 degrees, that would be the coordinates 0, 1, you could do the same thing. And this is pi degrees, or 180 degrees is minus 1, 0, and these are the quadrantal angles. 3 pi over 2, or 270 degrees, 0, minus 1. You can do the same thing with those. All right, let's talk about domain then. Okay, so the domain of the cosine and sine function is minus infinity to infinity, and the range is minus 1 to 1. If we draw a picture of our unit circle, we can see how this is, how sine t equals y is illustrated. We have a unit circle, and here's, we put it right with the origin there. So sine y equals sine t. So we've got our t going here, and 1, and this is 0, 1. So the y value, this is 0, minus 1. So t can go around and around and around and around, or negative way also, so the domain is associated with t. So the domain is minus infinity to infinity. But the y only goes between 1 and minus 1. It takes on those values. Y is the range associated with y. And our y value is going between 1 and -1, but it includes those values, so it's 1, comma, -1. And that's that. So you can look at the unit circle and try to figure those out. It's also illustrated in your textbook. And I have these built-in notes posted, so. Okay, so,
One, under -1 be the other way around.
oh, yeah. Thank you. Okay. I don't know why I wrote it out. Okay, I wrote it right here. All right, so I was going to fill these in, the domain then of sine and cosine. Let's get rid of this. Is minus infinity, minus infinity to infinity for cosine. Domain of t, tangent is all reals except odd multiples of pi over 2. The range of sine is -1 to 1. Same with cosine. And the range of t, tangent t, is minus infinity to infinity for all real numbers. In this class, you're allowed to write all real numbers unless I ask for an interval notation. Okay. All right. So the next example pi over 2, pi over 4. So trigonometric functions at pi over 4 occur frequently. We can use the unit circle to find these. So they go through that. I have it in my filled-in notes. You know, you basically, you're going to want to make a triangle. And you've got one, and at 45 degrees, A is going to equal B. So we'll have two A's here. Using the Pythagorean theorem, a squared plus a squared equals 1 squared. And we solve that, we end up with a equals the square root of 1/2. We have to rationalize that is 1 divided by the square root of 2 times square root of 2 over square root of 2. And that's why we write it as square root of 2 over 2. So sine and cosine of pi over 4 is square root of 2 over 2. And then you can find the rest. You put those over each other to find tangent. That's 1. And I have it worked out on the filled-in notes. Cotangent is 1 over tangent is 1. Secant is 1 over cosine. 1 over, that ends up being the square root of 2. It's easier to take. Let me get that, make that bigger. So it's easier to take this version of sine and cosine and flip it, rather than the rationalized version. And cosecant is square root of 2 because it's 1 over sine pi over 4. And you may have to go back and look at it. I found my point P up here. My point P was square root of 2 over 2, square root of 2 over 2, by making a triangle and using the Pythagorean theorem. But I like to write it as 1 over square root of 2, 1 over square root of 2, when I'm finding secant and cosecant, because those are 1 over cosine. And it's easier to flip this. So flip it in this step rather than that step. All right. And I'm sorry I'm going so fast. You were supposed to watch this, and I don't know how many people did, but I think a lot of people did. But we have to keep up with this. The material just gets harder, and then if I have less time for just 2 materials. So, okay, so 13. So this goes through a bunch of slides. These slides are posted in Shobi, or maybe even in D2L. Okay, now we're going to talk about if the functions are even or odd. So cosine and secant are even functions. Why? Because I've drawn them and they're symmetric with respect to WRT, the y-axis. And then the rest of the functions, sine, tangent, cosecant, and cotangent, are odd functions. So, because they're symmetric with respect to this origin. Odd functions were symmetric with the origin. So from 1710, even functions are f of minus x equals f of x. And odd functions mean that minus f of x equals f of minus x. So that means that since cosine is even, it means we can use this even property. If we have cosine of negative t, we can just replace that with cosine of t. And if we have sine of negative t, we can just replace that with negative sine of t. I've kind of written it the other way here. I flipped this here. Because sometimes you'll have a cosine or sine of a negative number, and you'll want to use identity, and you got to get rid of the negative inside the angle. And that's how you do it. You use the properties of sine and cosine. So the even odd principle so here's all the properties because of what you learned in Math 1710 about even and odd functions. If we have a negative angle, we want to rewrite it as a positive angle. It's okay that it has a negative sign in front of it. These are how we do that with even and odd properties. Illustrating the even and odd principle on the unit circle, That's page 541. In your book. And I think I'm going to just let you look at that in your book. So let's go ahead and do number 14. I'm skipping that. Okay, so if we want to find secant of negative pi over 4, we want to write it in terms of a positive. Secant is an even function, so that equals secant of pi over 4. And that is 1 over cosine of pi over 4. We found cosine of pi over 4 was 1 over square root of 2. Flip that, you get the square root of 2. Secant is an even function. We use the fact that secant is even. Okay, sine is odd, so this is going to equal minus sine of pi over 4. And that's minus 1 over square root of 2. Or if we rationalize the denominator, minus square root of 2 over 2. You want to rationalize it. You want it rationalized for sine, but you want to use it in this form when you're trying to find secant, because it's just easier to flip it. And these are the ones you need to memorize these. So basically, if you memorize these, if you know these are just these flipped. And if you know this one, and you know that cotangent is 1 over tangent, you know that one. So memorize those. Okay. And so now if you're given two of the functions, sine of t equals 2/3 and cosine of t equals that, then we can find the rest of the 4 remaining trig functions using these properties. So if we need to find tangent of t, it's sine of t over cosine of t is 2/3 over square root of 5 over 3. You flip it and cancel, or these 3's cancel. You get 2 over the square root of 5. You need to rationalize that. Square root of 5 over square root of 5. It's 2 square root of 5 over 5. That's tangent. Okay, cotangent of t is 1 over tangent. But we want to take tangent before we rationalized it to flip it. So we're going to take the reciprocal of a fraction, you just flip it. So that's the square root of 5 over 2. I ran out of room to write it the way I like. And then cosecant is 1 over sine. So flip that, you get 3/2. And then secant t is 1 over cosine of t. Memorize these. Flip that, you get 3 over the square root of 5. Rationalize it. You get 3 square root of 5 over 5. Okay? So you can be given two functions like sine cosine, and you can find in all the rest. Practice these. All right. Using the Pythagorean identity. So here's the Pythagorean identities. Memorize. Sine squared t plus cosine squared t equals 1. If you memorize this one, you can find the rest of them if you have this memorized and these memorized. So I don't actually memorize these. What I do is I take sine squared t plus cosine squared t equals 1. If I want secant squared, I'm going to have to divide the whole thing by cosine squared. Divide each term by cosine squared t. And you get sine over cosine is tangent squared t. Cosine squared over cosine squared is 1. And 1 over cosine squared is secant squared t. And you can do the same thing with this one, but just divide by sine. It's written in your filled-in notes. So, actually, we got pretty far. Let me do the last one, I guess, on this page. Periodic. Okay. Okay, so if you're given that sine squared t, let me get rid of that. Sine squared t, or sine t is 1/2, and t is between 0 and pi over 2. Find the value of cosine t using a trigonometric identity. We're going to use the Pythagorean identity. Sine squared t plus cosine squared t equals 1. We're solving for cosine squared. We either can solve this equation for cosine squared right here, or we can plug in the 1/2 squared plus cosine squared t equals 1. That's 1/4 plus cosine squared t equals 1. Subtract the 1/4. Cosine squared t equals 3/4. Take the square root of both sides. Because we know it's between 0 and pi over 2, we have to do the plus or minus sign. So we get cosine t equals the square root of 3 over 2. I took the square root of 4. And so I skipped a step there, but I took the square root of both sides. All right, well, we will start there next time and start on 3, whatever, 4, 3.